Fair enough. Yeah. So, what other factors does he need to bear in mind for that will affect the rate of swell then?
Okay, yeah.
Obviously, we got water and the type of water, but yeah, temperature.
But yeah,
Yeah,
temperature will affect it. If you think of water as being a mobile liquid,
yeah.
the warmer the temperature of the water, the more fluid it becomes. If you go to an extreme and you freeze the water, there's obviously no mobility there. So temperature is very important in the mechanics of the water moving into our product. But also at a higher temperature, our material will be slightly softer in essence, which allows it to expand that little bit easier. So temperature is one factor, but it isn't the discerning factor out in the environment. When we look at environmental conditions, we're essentially looking at two really important factors. The first one is pH. And
Right.
obviously,
Yep.
we say that in the lab, we test in deionized water, which has a neutral pH. But if you move into a lower pH value, into an acidic value, or you move into a higher pH value, such as an alkaline, or lime water, as we call concrete water, that will have an impact on the level of swell. And what
Yep.
you can do, you can select a grade of material with a higher or lower optimum expansion level to compensate for the environments that it is put in. The second environmental condition, which is very important, is salinity. And a lot of these factors within the environment which affect the rate of swell are connected with the ions that are present within the water.
All right. Yeah. 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 Yeah.
So if you look at the salinity, the salt concentration of a material, we test in deionized water. So we have a grade, for example, WS 25E950. This is a 25 Shore Air product, which swells to 950% in deionized water. That is its standard test requirements. But when you introduce that into a saline solution, a 3% saline solution, that will only swell to 250%. Now,
Much less then because of
much
this,
less,
because of
yes.
the salt concentration.
Yeah,
Yeah.
because the
Okay.
ions that are present, they affect the
Yeah.
way that the swell additive reacts to bringing in water into the system.
Yeah.
So you need to evaluate initially what kind of pH the water will be going into, and then also the salinity of that particular water medium.
Okay. Yeah. So is there anything we can do if he wants to use the product then in a high saline uh, environment? You
Yeah,
know.
well, for those kind of conditions where you've got a very high degree of salinity, we've developed the Dryflex WS Plus range,
Okay.
which
Yeah.
are
Yeah.
designed to swell in an 8% saline solution. So that's a very high concentration.
Very high concentration of salt.
Yeah.
Yeah.
And this product will swell to 300% within that 8% saline solution. So
Right. Okay.
it's a
Yeah.
very, very high level of swell under those conditions.
Okay. Yeah. So if he took the material for the in the high concentration of saline,
Yeah.
could he also use that for his standard products?
No, the problem with that is that if you revert that particular product to deionized water,
Yeah.
you'll actually get it to swell in excess of 3,000%.
Right. Okay. Yeah. Right. Yeah.
So it will
That's
be a very
yeah.
high risk swell, and potentially that may cause the material to break apart because you're expanding that polymer so much.
It's beyond it's beyond its strength.
Yeah,
Yes.
that's
Yeah.
it. Yeah,
Yeah.
it's designed specifically for saline solutions. So our standard Dryflex WS series can be used in deionized water or water of various environmental conditions, up to 3%. But when you're looking at the high salinity, you require the Dryflex WS Plus range, which
Oh,
are only
yeah.
for coastal areas.
Only for high saline
Yeah,
concentrations.
that's right. Yeah.
Okay. Yeah.